Imagine waking up in a city with a blue sky, trees, parks, apartments, and children walking to school. You pour a glass of water, step outside, and feel your full weight beneath your feet. At first, almost everything feels like Earth, until you look up. Instead of an endless sky, the landscape curves above you. Thousands of meters overhead are more homes, more trees, and entire neighborhoods hanging upside down from your point of view. Because this city isn't on Earth, it isn't on Mars, and it isn't on the Moon. There is no planet beneath your feet at all. The entire city is a gigantic structure rotating through space. That rotation could make the ground beneath you feel remarkably similar to Earth gravity, an idea researchers have studied for decades, although building it at city scale remains far beyond anything humanity has achieved. And gravity is only the beginning. Every breath, every glass of water, every meal, even the sunrise outside your window would depend on systems humans had to build. So the real question isn't whether we can construct something enormous in space. It's much harder. Can we recreate enough of what Earth gives us for free that 1 million people could eventually call a manufactured world home? The strangest thing about this city may be how quickly you stop noticing that it is moving. You get out of bed, your feet press against the floor. You pour coffee, and it stays in the cup. A child drops a toy, and it falls. But none of this is happening because a planet is pulling everything downward. The city is rotating. As the habitat turns, its floor continually pushes residents toward the center of rotation, creating the sensation of weight against the surface. With the right combination of radius and rotation speed, engineers could design parts of a large habitat to produce acceleration close to what we experience on Earth. NASA researchers have studied this principle and the human problems that come with it, including Coriolis effects and motion sickness. And this creates something no natural city has. Travel inward toward the rotational axis, and your apparent weight decreases. Near the center, you could experience near weightlessness. Then return to the outer neighborhoods, and Earth-like weight comes back. Gravity has become something humans can design into the architecture. But solving gravity doesn't create a world, because Earth gives us something even more important without asking us to think about it. Everything required to stay alive. And inside this city, humans would have to rebuild those systems themselves. Every morning, you drink water without wondering where the next glass will come from. Inside this city, that assumption would be dangerous. Water from showers, sinks, humidity, even waste, would have to be recovered, cleaned, and used again. We already do part of this in space. NASA demonstrated 98% total water recovery aboard the International Space Station, while its life support systems also remove carbon dioxide and generate oxygen from water. But keeping a few astronauts alive is nothing like supporting an entire city. Now at breakfast, a population this large couldn't depend forever on food launched from Earth. Farms would need to become part of the habitat itself. NASA is already researching space crops and bioregenerative systems, but feeding a city this way would require agriculture far beyond anything operating in space today. And those plants might eventually do more than provide food. They could help recycle water, refresh air, and give residents something psychologically important. Nature, trees, humidity, green spaces, even the daylight above them could be engineered. In a world humans built themselves, sunrise could become infrastructure. But that creates a frightening dependency. Your water, air, food, and environment now depend on technology working every day. So what happens when something doesn't? Imagine you're making dinner when an alert appears. A pressure sensor has detected a leak somewhere in your district. You don't run for a spacesuit. Doors automatically isolate the affected section while air is redirected and maintenance crews search for the problem. Then another warning appears. Part of the power network has failed. Backup systems take over. Water treatment continues. Air keeps circulating, and your family finishes dinner. That would be success, because in a city surrounded by vacuum, safety wouldn't mean preventing every machine from ever failing. It would mean something can fail without becoming a disaster. We already see the beginnings of this challenge in spacecraft. NASA's life support systems manage pressure, oxygen, ventilation, carbon dioxide, water, and other conditions, while researchers studying future long-duration habitats identify reliability, maintenance, and spare hardware as critical problems. But a permanent city would need to go much further. It would need redundant systems, replacement parts, local manufacturing, trained crews, and enough reserves to survive without immediate help from Earth. And when failures become something ordinary people barely notice, something important changes. Residents stop spending every day trying to survive. They start building lives. And that may be when this experiment becomes a real civilization. A child born here wouldn't wake up amazed that their city is floating in space. They'd worry about being late for school. Adults would commute to work, meet friends, complain about crowded transport, eat at restaurants, and return home at night. But their version of ordinary life could still look strange to us. Near the outer neighborhoods, rotation could provide something close to Earth-like weight. Move closer to the axis, and effective gravity becomes weaker. The unusual motion inside rotating environments could also produce Coriolis effects, one of the reasons researchers study how humans might adapt to them. Over generations, people might turn those differences into culture. Sports could emerge around different gravity zones. Architecture could exploit spaces impossible on Earth. Neighborhoods might develop their own identities, traditions, and rivalries. And every evening, an engineered daylight system could gradually dim until an artificial sunset crosses the habitat. The strangest part wouldn't be that humans learned to live inside a machine. It would be that eventually, the machine stopped feeling like one. And once one manufactured world could genuinely become home, humanity would face a much bigger question. Why build only one? One successful habitat would prove something extraordinary. Humans wouldn't necessarily need to find another Earth before building another world. The next habitat could be larger, then another could follow. Some might specialize in agriculture, others in manufacturing, research, or residential life. But getting there would require solving perhaps the hardest problem in this entire idea: building at enormous scale and space. A comfortable rotating habitat producing near-Earth gravity at low rotation rates could require structures measured on the kilometer scale. NASA-backed advanced concepts have explored both kilometer-scale, deployable structures and robotic systems capable of constructing rotating habitats that grow over time. These remain concepts, not cities under construction. Eventually, launching every beam, wall, and radiation shield from Earth may make little sense. Future builders could instead use material obtained beyond Earth and manufacture more of the structure in space. NASA is already researching in-situ resources and additive construction, although today's work is only an early technological step toward anything approaching this scale. And that's when the idea becomes bigger than one space station. For almost all of history, geography decided where humans could build civilizations. Coasts, rivers, continents, planets. But if we could manufacture the environment itself, civilization would no longer need to begin with a habitable piece of ground. And that changes what we mean by a world. What counts as a world? At the end of the day, the city begins to dim. Not because the sun has disappeared below a natural horizon, but because somewhere inside this structure, humans decided that evening should begin. A resident walks through a park while children play nearby. Apartments glow along the landscape. Restaurants fill. Families return home. And somewhere beyond the habitat walls is Earth. For someone born here, Earth might still be extraordinary. It might be the birthplace of humanity, the world their grandparents remember, and a place they hope to visit. But home? Home could be this: a place where gravity comes from rotation, where water is recovered instead of discarded, where farms, air, daylight, and even the environment itself exist because generations of engineers learned how to recreate pieces of what Earth once provided automatically. Nothing remotely like this city exists today. Building one would require breakthroughs in construction, closed-loop ecosystems, radiation protection, and reliability far beyond our present capabilities. Rotating habitat concepts remain exploratory, although NASA-backed studies have investigated artificial gravity, radiation shielding, and structures that could grow through in-space construction. But that's what makes the possibilities so profound. For almost all of human history, nature decided where civilization could exist. One day, humanity may begin deciding for itself.